we are beginning Chapter 1, Section 3. But before we get too far, let's start with the story problem to refresh our mind on setting up equations. So let's read through this story problem. As you can see, I've already identified the important information. Your school's drama club charges $4 per person for an admission to a play. The club borrowed $400 to pay for the costumes and props. After paying back the loan, the club has a profit of $100. How many people attended the play? Okay, so let's look at what we have. We know it costs $4 per person, and we don't know how many people attended, so we're going to call that 4x. Now, before we can look at the full profit, we know that we're going to have the loan amount, so it's going to be $400 off however much they made to give us the profit, and the profit here was $100. So if we put this in words, money times number of people minus loan equals profit. So basically that is like a setup that you can look for. No matter what the numbers are, you know that you have to multiply the cost per person times the number of people, take how much you owe the bank, and then that will be your profit. So this is what we were given. So let's go ahead and solve. So first thing is we don't have anything to combine on the sides individually. So now we're ready to start taking and moving things across to isolate the x. So I'm going to box the x in to remind us that's who we're going to be isolating. So the opposite of subtraction, of course, is addition. So I'm going to add 400 to both sides. So I get 4x equals 500. And then to isolate the x once again, then we have to do the next step, which in this case is going to be the opposite of a multiplication. So the opposite of multiplication is division. So I divide both sides by 4. So x equals 125 people. So 125 people attended the play, which then will give us a profit of 100. Okay, so we did our first story problem. I know it's kind of putting the cart before the horse, but this was more of like a warm-up scenario. So let's look at what we're going to be doing next. If we look at our 1.3 notes, this actually starts on page 14, but we are going to start on page 15. Let me take and clear this. All right. So we have a few problems on here that I want to work. So if you don't have a note packet or you aren't able to locate it, remember you can go onto our website, remember Kaufman's math class, and pull off a copy of the note packet. Or if you want to go into Google Classroom, I also have it linked in there. So without further ado, what we're going to do here is solve by having a variable on each side. So in other words, I need to isolate the variable, which means I have to get the variables put together. So if you look at example 1 here, we have 12 minus 3x equals negative 6x. Once again, we need to be careful with signs, but we're going to treat this a lot like what we did on the previous two sections. So we have nothing that we can combine on each side individually. So in other words, the left side is as simplified as you can get, the right side is as simplified as it gets. However, we do have x's on both sides. So since I have a variable on each side, I need to get them on the same side. Isolation means we get it to one side. So I am going to take and add the 3x to both sides because that is the opposite of subtraction. So 12 equals negative 3x. The last part of this is going to be looking at getting the x isolated once again. So this time now we're going to look at it as a multiplication problem. So the opposite of multiplication we know to be division. So I divide both sides by negative 3, and I get negative 4 equals x. Now remember, if your teacher does not like it wrote that way, you can rewrite it as x equals -4. As for me, I do not mind, but if you're not one of my students and you're watching this, you may want to make sure that you follow what the teacher asks. So let's move on. I want to look at number 3. Yes, I purposely skipped number 2 because I want you to pause the video at this point, do number 2. Did you pause it? Okay, so number 2 should have this as the setup. Now I'm not going to walk through it. Okay, so that is number 2 if you have questions. Now back to number 3. We have 3k plus 45 equals 8k plus 25. Let's go over a couple of good parameters for solving. First off, you always go through the steps. Now, we talked about the steps in section 2, so if you don't remember the steps, let's kind of briefly go back over them. Step 1 is combine like terms without going across the equal sign. So in other words, to make sure the left is all combined, make sure the right's combined. If there's nothing that's like terms that can be combined, then great, you're ready for step 2. Step 2 is combine like terms by moving across the equal sign. Now, remember, you do that by using opposite operations. So if it's positive, then it's going to be negative. If it's negative, it's going to be positive. Now, here's the tricky thing. I always tell students, no matter what, you need to move the variables first. You should always control the variable. So let's control the variable. If you have a teacher that's picky and always wants the variable on the left-hand side, great. I'm not so picky. So what I'm going to do is encourage the students to keep the variable positive when you get done with your work. So if that's the case, I'd like the 8k is bigger, so I'd like to keep it positive. So I'm going to subtract the 3k across. Now, the next step is then to subtract the 25 because I want to keep the 5k isolated. Or make it isolated, I should say. And the last step, the 5k is being held by multiplication, so we use division to clear that off and make the k isolated. So k is equal to 4, which is what we're going to rewrite. So remember, you can always flip it at the end. So now I want you to take a moment and do number 5. Yes, I skipped 4 on purpose. So I'm going to rewrite it for those of you that do not have your notes. And I want you to do the best you can on this. And these are all cues, by the way. So I'm going to pause the video and I want you guys to work this out. When you unpause it, the steps will be there. Okay, are you ready? Here we go. So the first thing we did was we combined the 2 q's on the right side. 2q and 1q made 3q. I subtracted the 3q across, got 2q, and then I recopied my problem. I next subtracted the 6 across so that the q could become isolated. So when I subtracted 6 across, I got -8. Last step. To undo multiplication, we know we divide. So I divided both sides by 2, giving me q equals -4. If you got -4, awesome job. If not, keep trying. I know this is difficult, but I know you can do it. Let's look at number 6 before we look at emphasis number 4. So for number 6, I have 8 plus 6x, sorry about that, minus 10x equals 16 minus 8x. Now, this is very similar to the one we just did, only this time we have a couple things to do. So step one, we rewrite it with these two here combined. Now, this one's a little different because we actually have negatives. We have to figure out what side we're going to move them on. So when I look at this, I have a -4 and a -8. Well, we know by the number line that -8 is technically smaller than -4. And I want a positive outcome. So if I add -8 becomes a +8 and I move it across, I'm going to end up with 8 plus 4x equals 16. Now you're ready to take and move the 8 across to isolate the 4x. So I subtract 8 across, and I get 4x equals 8. So can you guess what our last step is? Correct. Now you're going to divide both sides by 4. So x equals 2 is your final answer. Great job, folks. All right, so now we're on to this one. This one could be hard. It's number 4. So I'm going to change paper so we have more room and we're not as cluttered. Number 4 looks a lot more complicated than it actually is. We haven't got to this yet, but the fraction parts really are not as difficult as you may think. So let's just take it one step at a time. So we're going to take distributive property first. Now we just did distributive property in 1.2. So we know distributive property means we are multiplying it through the parentheses. So 3/4. Now I know that you like to use a calculator, which is great, but sometimes it's easier to do it in your head. This means that for each one of these, I am going to divide it by 4 and then multiply that outcome by 3. So 4 divided into 48 is 12. 12 times 3 is going to be 36. 4, and that right there is the first one. 4 divided into 16 is 4. 4 times 3 is 12. And we keep the negative sign because 3/4 is positive and -16, of course, is negative. So opposite signs means it stays negative. So now let's do the whole number on to the right. So I have 16 plus 8x. Now with this particular one, what we're going to do is we're going to move the smaller of the two over. Well, this time the smaller of the two is actually -12. So we're going to add 12 to the right. And I'm going to get 36 equals 16 plus 20x. So now we subtract the 16 across because we want to isolate the 20x. So I get 20 equals 20x. Now, at this point, you should know what our next step is. 20 and x are held by multiplication. Correct. It's going to be divide both sides by 20. So 1 equals x, or like we said before, x can equal 1. All right, so now that we've done the difficult one, let's look at the next page. On our next page, we are looking at basically the same concepts. So here's what I want you to do. Do 7 through 10, and we will check them. So take a moment, pause the video, and do 7 through 10. Now, for those of you that don't have this, this is what 7 through 10 looks like. So number 7 is here. Number 8. Make sure I don't fall off the page. Number 9. And number 10. as you notice, they seem to get longer, but the process is always the same. So as long as you remember the process is the same, then you will not have any difficulties working the problems. Let me scoot it up there. All right, so there are the 4 problems. Pause the video and let's work these through. Okay, let's see how we did. For the first one, you should have gotten A equals 3. So for number 7, you should have gotten A equals 3. Number 8, straightforward. Ran out of room down there, but B equals 4. Now 9 and 10 were a little more extensive, but nothing difficult. You had 2 distributive properties, and you had the negative 1R behind it. So what we had to do is take and combine that, make it 15, then take and start moving things across. So R should have been 5. Now number 10 had 2 quirks. Now yes, there's 2 distributive properties, but they're both negative. So you had to be really careful that when you distributed it in, you change the signs. So that's why the 16x and the 24, the 12x and the 30 are all negatives, because we were multiplying a negative number into them. And if you notice, they canceled out quite nicely. So once we've finished with that, you should have gotten x is equal to 6, or in this case, 6 equals x. Either way, it's the same thing. All right, are we feeling more confident? Okay, so this ends the first video for 1.3. There will be a second video talking about one solution, no solution, or infinite many solutions.